Means in a covalent bond, we know that there would be a pair of electrons has been shared. If it get attracted towards only one atom, that bond would be polar bond. And if it would be shared, if it gets shared equally, that would be non-polar. Okay, fine. In this case, why it has a negative charge? Because electrons are more towards the halogen as compared to carbon. And hence it becomes partially positively charged. Right? So when we move left to right in the period and when we move top to bottom in the groups, what happened about the electronegativity? Can you tell me?
So, ma'am, electronegativity increases across the group and it reduces below the, like, down the group.
As we go down the group in the periodic table, the size of halogen atom, what happened? It increases or decreases? Okay, fluorine, chlorine, bromine, iodine. Yeah. So top to bottom, atomic sizes increases, correct? Yeah. As atomic sizes increases, what happened? Their bond length means whenever carbon is bonded with the fluorine, carbon bonded with the chlorine, carbon bonded with the bromine, and carbon bonded with the iodine, these bond lengths are also increases. Understand? When we go top to bottom, what happened? Bond length goes on, increases. Right? Yes or no? So these things you need to keep it in your mind. So what is the nature of carbon and halogen bond? It is polar bond, right? Carbon has a partially positive charge and halogen has a partially negative charge, right? And bond length from fluorine to iodine, when it bonded with the carbon, goes on, increases when you move top to bottom in the group. Okay? Clear? Hello? Fine. Sandana, you can respond me because Aditi, she's out and she said like she cannot respond meanwhile. So.
Yes, ma'am. Okay.
So if I asked you something at least, because I feel like I'm taking a class, I don't want to babble only. Okay.
Okay, ma'am.
I'm going to remove all these things. Yeah. The next point we are going to see about the preparation of haloalkanes. Right? So several ways are there for the preparation of haloalkanes, right? That we are going to discuss now. Just give me a while. The first method is what? Preparation from alcohol.
Alcohols and halogenic acids.
Yeah. By using alcohol, how we supposed to prepare it? So in the C, the hydroxyl group of an alcohol is replaced by halogen on reaction with the concentrated hydrogen acid. So what are the hydrogen acids?
HCl, HF, HBr, HI.
Very good. HCl, HF, HBr, HI, etc. Correct? So when these get reacted with the alcohol, what happens? You will get alkyl halide. So what would be the general reaction for this? When ROH, what is the R? R group is any alkyl group connected with the alcoholic functional group. It would be a either primary or secondary alcohol. Okay.
It forms R, like RX and H2O.
Yes. When it will be get connected with what? HX. Any hydrogen acid. Right? It would be get connect when it reacted with any HX, what you'll get? RX plus H2O. This is your general reaction. Correct? And this will be what? Alkyl halide. Isn't it?
Yes, ma'am.
Yeah. I have written here primary and secondary. What is the basic difference in between primary and secondary, girls?
Ma'am, in primary, the carbon carbon is attached to only one carbon atom and other all are different groups like hydrogen or any electrophile groups, while in secondary there are two carbon attached to the main carbon atom.
Okay, fine. So the basic difference in between primary and secondary, how you have to keep it in your mind. Suppose here it's a OH group. This is your functional group, right? If this functional group is attached to the carbon which attached to another two hydrogen, right? Then it would be primary, right? And when the carbon attached to, sorry, this OH group is attached to the carbon which has only one hydrogen group and another would be the either aryl or alkyl group, same or different, right? That time it would be secondary group and this would be the primary group. Keep it in your mind always. It's very basic, but then very important. Clear? Fine. After that, see, very important reaction in this. Similarly, when alcohol is reacted with sodium bromide, what would be the reaction? ROH reacted with what? NaBr. What is this? Sodium bromide. Right? With in presence of your hydrogen acids, that hydrogen acid would be the sulfuric acid we will take now, H2SO4. In presence of sulfuric acid. What you will get? Obviously, your main purpose is what? You have to prepare haloalkanes, right? So alkyl group is here. It must be goes with what? Your halogen. Halogen is here. So your first and basic product should be R. Come on, tell me. Br. Correct? Yes, Chandana?
Yes, ma'am.
Hello. Yeah. So what would be the other products now? What else remain? Na is there, right? Hydrogen is there. Sulfate group is there. It will form NaHSO4. What is this? Sodium hydrogen sulfate. Yeah. Sodium hydrogen sulfate and H2O. Correct? Yes. Check whether it is balanced or not. You can see here one hydrogen over here, then two hydrogen over here, three hydrogen this side, also hydrogen here, two hydrogen here. Number of alkyl groups you can check. Sodium you can check. Bromine is also you can check, isn't it?
Yes, ma'am.
So it's a balance equation. Clear? Yeah. Shall I erase it? I hope you have written. Are you writing?
Yes, ma'am. I have completed it.
In short.
Now, one more reaction we have to see when alcohol is react with phosphorus halides. Phosphorus halides means what? Either phosphorus pentachloride or phosphorus trichloride. 3 PCl5. These are what your phosphorus halides. Okay. When your alcohol is reacted with PX3, any of phosphorus pentachloride or trichloride, you can say PX3, you will get generally what? RX plus what we will be formed?
POX and
Here see, OH, phosphorus is there. What is the formula for phosphoric acid? Formula for phosphoric acid, H3PO4.
H3PO4.
Right? You need to balance it. Here, how many? 3 hydrogen. Here only 1. So I need to multiply it by 3, correct? Yeah. And 3 alkyl groups are here. Here only 1. This is also need to be multiplied by 3. And when you multiply by 3, obviously your X's automatically get balanced. Correct? Yes. where your X would
Yes,
be
ma'am.
either chlorine or bromine. Fine.
Okay, ma'am.
Fine. Yeah. Very important reaction in the preparation student. That is nothing but the reaction of alcohol with thionyl chloride. What is the thionyl chloride's formula?
Ma'am, could you repeat the question, please?
Thio group. Yeah. What do you mean by thio group? That things you need to keep it in your mind. This is very basic in a chemistry. While once like taking the name of this compound, we have to take in this manner. Thio group means sulfur must be there in that. Okay. And azo group means nitrogen must be in that. Write down somewhere at the corner in your notebook. Okay. Azo compound means nitrogen compound and thio compound means sulfur compound. Now, here we are going to react our alcohol with thionyl chloride. Now, thionyl chloride means what? SOCl2. That you need to keep it in your mind. This is the thionyl chloride. And why it is important to react with alcohol? Because when we react it, obviously you will get your alkyl halide RCl. But then apart from that, two different products would be formed and those products would be in gaseous state. And as they are in a gaseous state, these like a product would be released into the atmosphere with ease and you will get your pure alkyl halide. You need not to separate. Understood? Clear?
Yes,
Why
ma'am.
it is important? Because in this reaction, when thionyl chloride is reacted with your alcohol, you will get alkyl halide, sulfur dioxide, and HCl. So sulfur dioxide and HCl, these two products would be into the gaseous state. And because of that, with ease, it will be released into the atmosphere and alkyl halide will be get it into the pure form. You need not to remove any impurities from it. And because of that, it is very, very important. Fine. Apart from that,
Okay.
see, reaction with primary and secondary alcohol with rest all the halides like sodium halide or NABR, we can say. Then the hydrogen halide will be very smooth, but then it will take a little time. It won't be very vigorous. But then tertiary alcohol reaction is just processed by shaking the HCl at room temperature. Means it is very, very fast reaction. If you see the order of reactivity of these alcohols, tertiary alcohol react faster as compared to secondary and secondary will react faster as compared to primary. So this is the order of reactivity of alcohol, okay, with respect to hydrogen acids. We can say hydrogen halides as well. Okay. So this sequence also you need to keep it in your mind. Apart from that, one more very important reaction is there for the preparation with the help of alcohol. What is that? I'll let you know. Shall I erase it?
Ma'am, 1 minute.
Yeah, please go for it. Write down. Once you have done, let me know so I can proceed.
Yes, ma'am, you can scroll it down.
I'm gonna erase it. Fine. See now,
Oh, sorry.
apart from these all things, what we have to do, one more reaction is there with the alcohol, right? That is reaction of alcohol with red phosphorus, right? In presence of halogen. And these halogen can be either bromine, sorry, or iodine. Don't you pronounce it ever bromine, okay? It's a bromine and iodine. So you will get your alkyl halide, RX. So this X can be either bromine or iodine. Fine. Yes. So in this case, phosphorus iodide or triiodide are usually the reaction. Generally, if you see mainly while writing into the reaction, they may say it, in this reaction, you may get phosphorus, tribromide or triiodide, PBr3 or PI3. Okay. Phosphorus tribromide and phosphorus triiodide in C2. Now, what is this C2? C2 means in reaction mixture. Okay. This is one of the important terms. Most of the time, they use this term, C2. Means in a reaction mixture, these things are happened. Okay. And after that, by completion of the reaction, you will get your alkyl halide. Red phosphorus reacted with this halogen to form this intermediate, and it will be reacted with the alcohol to give you your product, alkyl halide. Fine. Clear?
Yes, ma'am.
Yeah. So now what we have done, we have prepared the alkyl halide by using the alcohol. But then you cannot, means like use same method for the aryl halides, isn't it? Means suppose this is a aryl group, your benzene. This is a benzene alternate double bond present in that, and it is attached to your OH. So what it is, it will be phenol, right? Right? So with phenol, you cannot do this kind of reaction. Means you cannot use this phosphorus trichloride, HCl and all to replace this OH group with the Cl and all. Why this is not happening or why it is not possible in this case? Due to the resonance. Do you know resonance? What is the resonance? Here what happened? On oxygen, what is present? Lone pair, right? Yes. And pair is means like continuously rotating on the ring. Suppose it will go here. This double bond would be shifted here, right? Then you will get the resonating structure in this manner. Suppose this would be another benzene. No, actually it won't be another benzene. It would be the same benzene, but then position of this electrons would be changed. Now oxygen's lone pair would be shifted over here. So it become double bond OH, and oxygen become electropositive in nature due to donation of the electron for the formation of double bond. Okay. And this double bond has been shifted as a negative charge at the ortho position of phenol. And this double bond would be as it is. Other two double bonds would be as it is. Now what happened? This negative charge again formed the double bond here. And this we shift here. Correct? You will get a resonating structure. Right? Now here it will be the negative charge. Here is the double bond as this negative charge has been formed here, single bond, and already one bond is present, so it becomes double. And here double bond OH with positive. Similarly, it goes over here. It comes again at the ortho position from the para position. You will get another resonating structure. Resonating structure is always shown by the double-headed arrow. Keep it in your mind. You will get what? Here. In this manner, another structure. Double bond, negative charge, double bond OH with a positive charge on it. Now here what happened? This will be go here, and this will go back to your oxygen, lone to your oxygen, and you will get your previous structure, this structure back. So what you come to know by this? The lone pair present onto the oxygen is in continuous rotation, right? It will undergo several resonating structure, and it is in a partially double bond form, right? Because we don't know where these electrons would be moving. If you say here it is till the time it will move entire compound or entire benzene, right? So you cannot predict it where it is exactly. Its location cannot be stressed, and hence your lone pair present onto the oxygen is always into partially double bonded, right? And because of that, we cannot use phenol for replacement with halogen. Hence, this reaction means preparation of aryl halides will not be possible by using OH group from the aryl group. Understood? Hello, girls, are you there?
Ma'am, so basically resonance means the phenomenon of existence of molecule in many structures. Like,
Yes, many structures, number of structures, but then those structures would be for only one compound. And we cannot predict the location of particular electron because they are continuously moving in that like cloud, electron cloud.
okay, due to the delocalizations of electrons.
Delocalization, yes, due to delocalization of the electrons, we cannot predict where it is present right now, and hence all the bonds are partially double bond and partially single bond in the aromatic compounds.
Okay, ma'am.
Understood? And hence, if
Yes, ma'am.
OH or any of the electronegative atom is attached to it with a lone pair, those lone pair will be utilized for the formation of double bond and delocalization of electrons. Okay,
Okay, ma'am.
fine. Clear? And hence, we cannot use the same method how we have made for the alkyl halides for the aryl halides. Clear?
Yes, ma'am.
Fine. Now, how we are going to form the alkyl halides with the help of alkane by using the free radical halogenation. Fine, that we will see. Preparation of alkyl halide by free radical halogenation. Fine. In this case, see what is given here. Free radical chlorination and the bromination of alkene gives a complex mixture, right, of isomeric mono or polyhaloalkanes, right, which is difficult to separate as a pure compound, and yield of any single compound is low. So how this reaction will be takes place? This reaction you have to like initiate by using the ultraviolet light or either sunlight. Sometimes you need ultraviolet light, sometimes you need to use the sunlight, or sometimes you have to use the heat for the cleavage of or preparation of radical. Okay, and once radical would be made, that radical may be attached to your primary carbon, it may be attached to your secondary carbon, and because of that, you will get a mixture of product, and it is very difficult to separate. And as there are these several products, what happens? Yield of the product is very low. For example, suppose here CH3, CH2, CH2, CH3. What is this? Butane, correct? Yeah. When it undergo free radical reaction in the presence of UV light or heat, what would be happen? This Cl would be form a radical. This half arrow indicate what? Only one electron has been shipped. Okay. And same thing is happened with this reaction as well. In this molecule butane, in this case, what happened here? CH3, CH2, CH2, C. Here would be hydrogen, here would be hydrogen, and here also would be hydrogen. So in this case, what happened? This hydrogen also get cleavage with one radical. And you will get the product in this manner, CH3, CH2, 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 and here what? Cl. This is your first product. But then instead of this hydrogen, if this hydrogen would be, if I'll use different color, you'll understand. Instead of this hydrogen, if here it has a two hydrogens, right? Here one hydrogen and here one hydrogen. If this hydrogen undergoes cleavage, you will get another product that will be plus CH3, CH2, C. Here it will be Cl, right? One hydrogen will be as it is, and here CH3. So what would be the IUPAC name for this alkyl halide and this alkyl halide? parent is butane, okay? So this attached to the first carbon, it will be 1-chlorobutane, right? And what about this? 1, 2, 3, 4. So this will be second carbon attached with the chlorine. So it will be 2-chlorobutane, right? So you get a mixture of product and each one of them have a less yield, right? Low yield. This is also under low yield, right? This is a method in which you are able to prepare a haloalkane by using a free radical halogenation. And it takes place with halogen in the presence of ultraviolet light or heat. Clear? Hello?
Yes, ma'am.
And then, yeah, understood?
Yes, ma'am.
See, this is for your first product. If this hydrogen has been replaced with halogen, then this is your first product would be formed. And if this hydrogen would be replaced with your halogen, then second product will form. Keep it in your mind. Okay?
Okay, ma'am.
Fine. So we'll move forward. We'll see the next reaction. Yeah. How we are going to form a alkyl halide by using alkenes. So what is the alkene first? Tell me. What are the alkenes? Alkenes has a general formula CnH2n and which contain carbon-carbon double bond, correct? These are the hydrocarbon which contain carbon.
Alkanes are the series of compounds that contain carbon and hydrogen atoms with single covalent bonds.
Alkane not, I'm asking alkene. See here spelling.
Oh, sorry.
E-N-E. Correct? I asked you for E-N-E. So alkenes are the hydrocarbons which has a general formula CnH2n and which possess what? Carbon-carbon double bond instead of single bond. Carbon-carbon single bond would be for alkane, I know. And if I have added here +2, that would be the general formula for alkane. Clear? Yeah? Fine.
Yes,
but then currently we are speaking about what? Alkenes. Right? Now, when we add hydrogen halides, means HX, to the alkenes, that time what happened? Addition reaction will be takes place, right? You might have learned addition reaction in your grade 10th or 11th, right? Yes or no? So this addition reaction with hydrogen halides will give you the formation of alkyl halide, correct? And in that case also you may get two products and one would be the major and other would be minor. Which rule you have to follow for that? There are the two rules, right? Markovnikov's rule and Setzev rule. I hope you have learned it in your grade 11. Fine. See, I'll let you know what would be the reaction in this case. Carbon-carbon double bond in a general, right? These are the, we are going to satisfy the valency for carbon. Okay. If it is undergo reaction with HX, it will form what? Addition. It will undergo the addition reaction. One hydrogen will go to the one carbon and halogen will go to the another carbon, correct? Because these electrons would be shifted here, carbon-carbon, and these are also would be shifted here. The carbon-carbon, hydrogen will go on the one carbon and halogen will go on to the another carbon. So you will get the reaction in what sense? Here, carbon, carbon, and hydrogen. This hydrogen will go here. Now, carbon, 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 and here it will be the halogen. Correct? So this is your general reaction for the alkyl halide. This is the alkyl halide generally. Now we are going to see the example. What would be the example in this case? CH3, CH, double bond, CH2. This is what? If you number 1, 2, 3, at the first position, carbon-carbon double bond, right? So 1, propene, correct? Yes? Now,
Yes, ma'am.
you're going to react it with HI or HX. It's up to you. If I react with HI, what would be the product I'll get? Two product I may get. See, if iodine attached to this carbon, I'll use the different colors. You'll understand in a better manner. If iodine attached to this carbon, you will get one product. If iodine attached to another second carbon, you will get second product, right? And those product would be what? For the first one would be what? Here CH3, CH, right? If if iodine is attaching to the first carbon, then hydrogen will go to the second carbon. So it becomes CH2. And here CH2I. This would be your first product. Plus another product would be what? CH3, CH, right? CH3, and here it will be iodine. Clear? Fine. Yes or no? So check the valency. Valency should not be exceed than 4 for the carbon. Keep it in your mind always. Now, one product in this case would be major and another would be minor. So which one would be major and which one would be minor? Tell me. This is your primary alkyl halide, right? Because your halogen group is attached to directly CH2 group, which possess how many hydrogen? 2, right? And in the another second product, iodine is attached to the carbon, which is contain only one hydrogen on it and 2 alkyl groups. And hence it is secondary alkyl halide, right? So among that, primary or secondary is major for addition reaction with the Markovnikov's rule. Right? Major substituted alkyl halide would be a major product and less substituted alkyl halide would be the minor product. You can see this is the secondary alkyl halide, right? So as it is highly substituted, at the second position it has been substituted, so it is a major product. And as it is primary one, it is directly attached to the carbon, it's a minor one. Right? Keep it in your mind. Major and minor product. Right?
Okay.
So if secondary or tertiary would be formed, those would be major. And if primary would be formed, that would be minor. According to the Markovnikov's rule. Means what you have to keep it in your mind, halogen group will be shifted or will be goes to the carbon which is more substituted. So this carbon is more substituted with carbon group, right? Here one carbon, here another carbon. So whenever halogen group will go to this carbon, that would be the major product. And if you see about this primary carbon, what happened only, it is less substituted. It attached to only one carbon. And hence, when iodine goes to this first carbon, that would be the minor product. And this rule is called as what? Markovnikov's rule. We have learned it into the grade 11th. I hope you have learned, but then you know better, means like this concept has been cleared or not. One more opposite rule is there for the Markovnikov's rule, that is Sedzev rule. There are certain conditions, that time only we have to follow that Sedzev rule. Whenever certain condition would be there in our like learning, definitely I'll clear it. I don't want to confuse you now about it. Okay?
Okay.
Yeah. So in addition reaction, what you have to keep it in your mind, when alkene react with halogen acid or any what we can say hydrogen halide, that time hydrogen will goes to the carbon which is less substituted and halogen will go to the carbon which is more substituted. Hydrogen goes to the carbon which is less substituted, halogen will go to the carbon which is more substituted, and that product would be major product according to Markovnikov's rule. Fine. That's it. If I give you one more example, can you write down the products? Yeah? Yes, no, speak up.
Yes, ma'am.
Right. So go for this reaction. Write down the two products. Do not write major, minor. That may confuse you, but then at least write down the products. What will happen in this case? CH3, CH, right? If hydrogen would come here, it becomes CH2, CH, halogen will become here as a Br. You will get here CH2, CH3. Plus another product would be what? CH3, CH. Here it will be the Br. And here CH2, CH2, CH3. Correct? Yes?
Yes,
What would be the name of the compound? 1, 2, 3, 4, 5. This will be what? 2 bromo, 1, 2, 3, 4, 5, pentane. Correct? And what about this? Here, from here also third, here also third. 1, 2, 3, 4, 5. So it will be 3 bromo, pentane. Got it? Yes?
yes, ma'am.
Yeah. So in this case, like we can't say this is secondary, this is tertiary and all, because both are secondary, right? This is also secondary carbon, this is also secondary carbon, and because of that only I said need not to go for the major and minor, but then at least two different products which are forming, that you need to understand how it will be formed, because halogen position will be decide the product. Clear? This all about addition, reaction of hydrogen halides with carbon-carbon double bond or alkene groups. Clear?
Yes, ma'am.
We'll go to the next concept. That will be halogen exchange. One more important thing is left behind. Let me clear about it. Fine. Yeah, this one. Addition of halogen. Have you gone through any practical or not yet? Any organic practical?
Not yet, ma'am. They are gonna do it at the year end before boards.
Oh, that's so like, pity. Actually, they should teach you through the practical way. That would be really convenient to understand the things. So this reaction to explain you right now, that is practically to detect whether carbon-carbon double bond is present into the compound or not in a laboratory. Okay. So here what happened, addition of bromine in the presence of carbon tetrachloride will be takes place. When we add the bromine, what happened, we get a vicinal dihalides. Vicinal and geminal difference already I told you, right? Geminal means what? Geminal halides means what? When two halogen groups are present on same carbon, right? And vicinal means what? Vicinity. Vicinity means nearby. Means two nearby adjacent carbon have a two different halogen group. Correct? So this is the basic difference in between geminal halides and vicinal halide. Already I have explained it in the previous class. Now what you have to keep it in your mind, whenever carbon-carbon double bond bromine, okay, mostly it is called as a bromine water, right? Liquid bromine, bromine water in presence of carbon tetrachloride, CCl4. What happened? Addition of this bromine will be takes place with this double bond, right? Means carbon-carbon double bond will be get clipped, and what? Here bromine would be attached. Correct? Means both bromine, one bromine will go to the one carbon, another bromine will go to the another carbon. So this is what? Two halogen groups. So this is dihalide. Okay. What you get? Vicinal dibromide. alkane, whatever it will be. Okay. It may be butane, propane, pentane, whatever it will be, vicinal dibromide alkane. Now, in this case, what happened earlier in the compound, double bond. And now after the formation, there won't be double bond. So what happened exactly? We know that bromine water is a brown in color, right? Compound must have certain color, either have or it won't have. But then if carbon-carbon double bond is not present in that compound, bromine water's brown color will be remain as it is, or that color may change. But then that solution after addition of bromine will be colorful. Okay. But then if you add the bromine water into carbon-carbon double bond compound, and it will form a dibromide alkane group, vicinal dibromide alkane will be formed in that compound. That time, as we know that carbon-carbon double bond is converted into carbon-carbon single bond, right? Here it is what? Double bond. Here it is what? Single bond. Due to this, what happened? Your compound color will be completely vanish and it become decolorized. Decolorized, right? And when in a reaction, decolorization would be appear, you may confirm what your compound has carbon-carbon double bond, and hence it is a detection test in the practical to detect whether the carbon-carbon double bond is present into the given organic compound or not. Understood? Fine. Hello.
Yes,
This is very, very important test. You practically have to perform it. Understanding? You have to perform practically these things.
ma'am, like
So,
this year.
yeah, obviously in this year, because for 11th, 12th also, we have, as per my knowledge, in a syllabus of the 12th, this has been added. I don't know why they have not taken you yet in lab, because if they have started with this, immediately they supposed to take you in a and show this test. Understanding? What? When bromine water's color, brown color would be disappear and it convert into the water. That time, what you have to come, what you have to think? Carbon-carbon double bond would be present or absent. If decolorization is happened, carbon-carbon double bond present. And if there would be the change in color, suppose brown color would be changed into green color, brown color would be changed into orange color, or brown color remains brown color, or a black color. That time change in color happened. That doesn't mean that there is a carbon-carbon double bond. If totally color is being changed and you get a liquid like a water, then it is decolorized water, decolorization, and we can say carbon-carbon double bond is present in that compound. Okay. This is one of the important tests. Shall I erase it now?
Yes, ma'am.
Fine. And the next one is replacement of halogen. Right? Halogen exchange, we can say for it. Okay. That will be what? Halogen exchange reaction. This is also one of the method by which we are able to prepare alkyl halides. Means generally alkyl halides are of a bigger molecule like chlorine and bromine will not be possible easily, right? And we know that metal halides are present like sodium chloride, sodium iodide, sodium fluoride are there. But then among that sodium iodide, iodine is a largest into the size, correct? As compared to fluorine, chlorine and bromine. As we go down the group, this would be the sequence: fluorine, chlorine, bromine, and iodine. Clear? And top to bottom atomic radius is increases as we have learned earlier. Right? So alkyl iodide are often prepared by the reaction of alkyl chloride or bromides with sodium iodide. Correct? Sodium iodide will be what? Metal iodide. Sodium is a metal in presence of dry acetone. And this reaction is known as Finkelstein reaction. Keep it in your mind. The reaction, what I'm going to explain you, that would be which reaction? Finkelstein reaction. In Finkelstein reaction, what happened? Your alkyl halide Rx right? React with sodium iodide, NaI. This is a metal iodide. Yeah. Replacement halogen would be takes place. X would be replaced by iodine, right? You will get Ri plus NaX, right? Where X would be either chlorine or bromine. Clear? Fine.
Yes, ma'am.
Wonderful. Fine. So this would be your last preparation reaction for the haloalkanes. Haloarenes preparation we are going to see soon. I think time is up. It's 9:15 was our time and I have extended for 5 minutes because you have joined little late. I hope the concept which I taught you about the preparation, you have understand and you have noted it. So regarding that, I have few questions. I'm gonna post it, okay, as an assessment. Please try to solve it, okay? And if you have any query, feel free to ask without any hesitation. My number is already there in a group. You can personally also text me. Okay? Hello?
Okay, ma'am.
Shall I end the class now?
Okay, ma'am.
Yeah. Take care, students. Bye.
Thank you, ma'am.